So we are doing stoichiometry, and stoichiometry, in case you don't know, it sounds like a cool name. Really, it just refers to all the mass relationships in chemical reactions. One of the best metals that we use is aluminum, except for the fact that it might cause Alzheimer's, but it's unlikely. We use a lot, and aluminum oxide is a very electricity-intensive process. What we want to know is if we have 120 grams of aluminum and we are reacting it with all kinds of oxygen, what mass of aluminum oxide are we going to get? Now, often in these problems, things are given to you like what the formulas are, what the balanced equation is. Well, often not what the balanced equation is. First of all, we have to figure out what the formula for aluminum oxide is. Aluminum and oxygen, pretty straightforward. But we need to figure out the formula for aluminum oxide. And so if you might remember from grade 10, aluminum, if you check your periodic table, which you'll always has a valence of 3 plus. Oxygen has a valence of 2 minus. And so aluminum oxide, you might remember this crossover method that you use to produce a particle that has a balanced charge. We need 2 aluminums and 3 oxygens for this to be a particle that doesn't have any charge. Okay, the next thing is to go to the most important step. Everything revolves around the balanced chemical equation because everything comes down to interpreting the ratios once we figure out how many moles of each are present. And so we have Al2, O3, and that's going to be a solid. All right. We're going to balance our metals first, so we need 2 aluminum here, and we have 2 oxygen here. We need 3 over there. So I'm going to kind of do this sheeting method first of all. I'm going to say we have 3 halves of an oxygen molecule, and depending on who you had in grade 10, they might have told you that that's a crime. And so what we're going to do is just multiply this whole thing through by 2. And so we have 4 aluminums, we have 3 oxygens, and we have 2 aluminum oxides. Did I get that right? I think I did. Okay. In order for tomorrow's lesson to go kind of a little bit better, I'm going to get you to put a table underneath this. Okay? The notion of the table is it's going to help you keep all the quantities and the ratios straight. Okay, so this is essentially a 4 to 3 to 2 reaction. So for every 4 moles of aluminum, I'm going to get 2 moles of aluminum oxide, which is really just 2 to 1. If I were working with oxygen, this ratio of 3 is kind of important. The next row in the table, and so this is our ratio roll, and the next one is the mass row, the molar mass row. And the molar mass of aluminum is 27 grams. Molar mass of oxygen is 32 times 3, which is 96. And the molar mass of aluminum oxide is 102 grams. Am I right? Okay. So there's my molar mass row. Here's my actual mass row, and I'm just looking at it. Maybe we should have put the actual mass on top just because we're going to be doing we're going to be dividing it the other way. We have 120 grams of aluminum, and that's the only mass that we really know. We have excess oxygen, and what we want to know is how many grams of aluminum oxide are we going to get? Obviously, I have more than 1 mole of aluminum. I'm going to figure out how many moles of aluminum I have just by doing that one calculation, 120 divided by 27. 4.44 moles. So I'm down in the bottom row of my table now. I figured out I have 4.44 moles of aluminum. Ho ho! Things are really getting crazy on my table. My ratio is 4 to 2 or 2 to 1, and so I'm going to have 2.2 moles of aluminum oxide. Every mole of aluminum oxide weighs 102 grams. And so all I need to do is multiply 2.2 by 102. And so there are 224.4, which is one more than I really should be carrying, 224.4 grams of aluminum oxide are produced. And so basically what we did, we went from the grams of the reactant to the moles of the reactant. We used our balanced chemical equation in the ratios to go to the moles of the product, and then we went from the moles of the product back to the number of grams of the product. Okay, so sometimes we say mass to moles to moles to mass.